Chemical kinetics is a branch of physical chemistry that deals with the study of chemical reactions with respect to reaction rates, effect of various variables, rearrangement of atoms, formation of intermediates and other mechanism of reactions. The birth of chemical kinetics is often taken to have occurred in 1850, when a German physicist, Ludwig Ferdinand Wilhelm Ley, studied the rate of inversion of sucrose.
To explain the different rates of reactions, Max Trotz and William Lewis came up with collision theory in the early 1900s. The first assumption of collision theory is that the particles must collide with one another in order to react. Most particles will act like billiard balls in a game of pool, and when they collide, they bounce off each other. The collision itself isn't all that's needed for a reaction to occur. The particles also need to have enough energy, enough speed, to break and form new bonds when they collide. The minimum energy required for a reaction to occur is called the activation energy. Some reactions require very little, and some need a lot more to get started. Generally speaking, most reactions will occur faster when the temperature is increased, because temperature is the average kinetic energy of the particles. With more kinetic energy, they will be more likely to have enough activation energy for the reaction to occur.
In this experiment, the objectives are the following. First, to evaluate the hydrolysis of methyl acetate by studying its chemical kinetics. Second, to quantify the activation energy requirement of the reaction. Third, to familiarize the students with the use of acid-base titration in this study. Fourth, to determine the effects of temperature and concentration on the hydrolysis rate, and fifth, to determine the change in enthalpy and change in entropy of the reaction. The materials used in this experiment were water trough for ice bath, stopwatch, Erlenmeyer flasks, graduated cylinders, burette, and pipette. The reagents used were prepared first before proceeding to the actual experiment. 350 milliliters of 1 molar hydrogen chloride, 50 milliliters of water, and 10 milliliters of methyl acetate were transferred into 3 250-liter Erlenmeyer flasks. Also, 10 150 milliliter Erlenmeyer flasks were filled with 50 milliliters of distilled water and were placed on an iced bath to make sure that the hydrolysis is sufficiently slowed. 5 milliliters aliquot of the reaction mixture was immediately transferred into a 250 milliliters Erlenmeyer flask, which was pre-chilled in an ice bath and contains 50 milliliters of water. The diluted aliquot must then be titrated as soon as possible with standard sodium hydroxide solution, using phenolphthalein as indicator. The procedure will be repeated at 10 minutes interval for 1 hour, and 20 minutes interval for another hour. The whole procedure will then be done at 35 degrees Celsius, and again at room temperature but using 100 milliliters of hydrochloric acid and 10 milliliters of methyl acetate as the reaction mixture. This reaction will proceed more rapidly. The hydrolysis rate of methyl acetate was determined in this experiment by analyzing its chemical kinetics at room temperature and at 35 degrees Celsius. In evaluating the behavior of a system, it is necessary to know the equilibrium conditions, but it is frequently necessary to know also the speed with which the equilibrium is attained. The results are treated as follows.